Hello and welcome to Empowered Learning. This particular lesson will be on how to sketch a graph of the inverse cosecant function using the cosecant function as its basis. So what we have here to our far left is a graph of secant x, which is in the black, which is based upon sine x, which is in the red. And so as you see, how we derive the cosecant function to begin with is that we take one full period for the sine x function, and you see that this particular period, I guess this particular function is from minus pi to pi, which covers a full period of 2 pi radians. And from there we just flip, or yeah, we just flip the points. So we see that the portion of sine x that has the upward hump like this, if we flip it about the 0.11, then it goes up like this. And the reason why we're flipping it is because, as we know, the cosecant function is just the reciprocal function of sine. So, of course, we know cosecant is equal to 1 divided by sine x. Now, of course, for the y-coordinate, this is the 0.11 for the sine function, and if we flip 1 over 1, it's still 1 over 1, but everything else is doing its flipping action here, and which is why the graph is going up this way instead of down like this for this portion. And similarly for the trough portion of the sine x function, we flip it and make it go the other way. So now that we have all that established, we see that some of our key points for cosecant are what I have listed here. And so I took the very simple ones to see what happens at minus, when x is minus pi over 2, as well as pi over 2, and then where our vertical asymptotes are. Just to be clear here, for this point here, you see that I have 0, then with a negative sign there, and vertical asymptote with a negative sign. I'm just describing the behavior. So what I'm saying here is we have a vertical asymptote at x equals 0, and on the left side of that, 0, the vertical asymptote is going down to negative infinity. So this negative sign here means that I'm coming from the left side of 0, and this particular negative sign means that the vertical asymptote is going down to negative infinity. Similarly, on the right side of 0, which is why we have the plus here, the vertical asymptote is going up to positive infinity. So just trying to be clear on what actually happens there. So now we know from some of the previous videos that we can derive our inverse cosecant graph from the points of cosecant by just interchanging them. And so what we have to watch out for here is what values of x we actually use. Now, if you notice, the x values that I'm keeping everything restricted in between will be from when x is negative pi over 2 to pi over 2. And the reason for that is, even though we know that the cosecant function itself is not a one-to-one function, meaning that the whole entire periodic function for cosecant wouldn't be an inverse. Of course, if we restrict our domains in between negative pi over 2 and pi over 2, that resulting function, which looks like this and looks like that down here, would be a one-to-one function. And so with that, we'll go ahead and write our points here. So instead of having negative pi over 2, negative 1, we have negative 1, negative pi over 2. And then we have, instead of a vertical asymptote, we would have a horizontal asymptote. Okay, so this would be a horizontal asymptote at y equals 0. And then, of course, horizontal asymptote at y equals 0 again. Now, this x equals 0 and then the negative set is coming from the left. So as we go towards the left, or negative infinity here, x equals negative infinity, we will be approaching the horizontal asymptote on that end. And of course, as x approaches positive infinity on this end, we will approach the horizontal asymptote of y equals 0. And so that'll help us be able to figure out how the graph looks later. And of course, our last point is negative 1 pi over 2. Sorry, 1 pi over 2. And so now that we sort of know what portion of the cosecant function we're actually using and the points, we're now going to produce the Cartesian plane for the cosecant inverse function, and then plot the points and graph. So now that we have our Cartesian plane up for the inverse cosecant function, we will go ahead and plot our points and then figure out how the profile of this graph looks. So we'll start off with the easy points first. We'll go ahead and plot negative 1, negative pi over 2, and 1 pi over 2. So negative 1, negative pi over 2 would be right here. And then, of course, 1 pi over 2 would be here. Now, we notice that for the horizontal asymptote, we have one that's going to the left that approaches y equals 0. And then we have one that's going to the right that approaches y equals 0 as well. And so we see from the point here on the left, the negative 1, negative pi over 2, if we're going to be approaching the horizontal asymptote y equals 0, we will sort of do this inward curve this way. And similarly, at the point 1 pi over 2, to get down to the line y equals 0 for the vertical asymptote, we would have to turn and go this way. And so that is how the graph of the inverse cosecant function would look.